Hi everyone, welcome back to the channel. I'm Hussein Younes, an AI engineer, and today we're going to be continuing our series on AI agents, building AI agents from scratch to production. In the previous two videos, we have talked about how to build an AI agent and give it access to tools. In the second video, we have learned the concept of memory and how to give our AI agent access to a memory to memorize the conversation and not forget the previous turns and messages that has been exchanged during a conversation. In today's video, we're going to be talking about conditional logic and branching because it's an important concept in building AI agents. So why we actually need branching? So what we have built so far in this series, we were using one LLM. So with a single LLM, we can actually solve maybe one or multiple problems based on the tools that we're using. But for some cases, we might actually need more than one LLM based on the use case that we want to resolve with different LLMs. So far, we have been using a one execution path, roughly, using one LLM. So we start the execution, then we execute the agent or the LLM node, then we go to the tools, we execute the tools, and then we end the workflow. So it's just one LLM. Real-world complexity example, let's say, for example, a customer support example, we might need more than one agent. For example, in customer support, there might be like a billing specialist, right? Like it might redirect you to the billing specialist if you want help with payments or like refunds, something like that. You might also need like a technical support, right? So the support team will redirect you to the technical specialist for bugs and errors, whatever. And for general support, you need like some general support specialist that knows generally that might answer your general questions to give you support. So one agent cannot like handle all these cases. So we need like multiple LLMs or multiple nodes to handle those cases. I'm actually going to go in depth in future episodes about multi-agent systems. I'm gonna maybe make one or two episodes about it and when actually it is like the best to use it or when not, because it turns out in some cases it's better to use just a single agent. But for example, for this use case, it makes sense to route the execution to multiple agents. Also, just to give you one example, one of the best AI agents in the world right now is Claude Code. It's like a coding agent, and it has this concept of routing and the multi-agents as well because it uses like sub-agents, and it routes the execution to the concerning agent or to the relevant agent based on the use case that you give it, and you can create these agents and route the execution to them, but that's not our topic. So let's see how actually the routing works in real life or in LangGraph. Yeah, so this is how dynamic routing works. So first the user asks a question. So we take the input, we receive the input from the user, then we categorize this input. We basically decide or choose or classify where to redirect this or where to route this request to. The router decision. So basically the router takes the category and redirects the query to the corresponding agent, can be in this case billing, technical, or general. So now let's see how this looks in LangGraph. How we can what are the main concepts in LangGraph that supports this. So we have a router function, and we have conditional edge, and we have state-based decision. So the router function, it examines the state and see where we need to route the execution next. So the conditional edge is basically not just one edge from one node to another, it's actually multiple edges. And based on the routing decision, we're going to use the edge that we're going to route the execution through. And the state-based decision, so this is basically the state. Okay, so now here's how the router function looks like. So we have a route to specialist function, takes the state as input, and then uses that state and returns target node name. So in this case, it's going to be either billing, technical, or general. So the category, it reads the category from the state, and then it returns basically the category, which is the name of the target node. Now, where we use that function, this router function? We're going to use it when we add the conditional edges, right? So we have, as I said, we will have like multiple target nodes, but a single source node. So therefore, we need to have like multiple edges. So this is how we define the multiple edges. We need the source node. So the source node in this case is the categorize node. And then we have the router function, which is going to be used to decide where to direct the execution to, and then we have the target nodes. So this is the mapping between the output of the router function and the names of the target nodes. So if the output of the router function was billing, then we go to the billing node. If it was technical, it goes to the technical node. If general, to the general node. So generally, it's like the same name, but the router function output can be anything, actually. It doesn't have to be technical, literally. It can be like technical node or something like that. But usually here in this case, like the names of the actual names of the nodes are the exact same as the output of the router function. That's why we have the mapping. So now let's go to the code. So this is how the graph looks like of the agent. So we have the starting node, we have the categorized node, and then we have the conditional edges. So these dashed lines means these edges are conditional. So we're either gonna go to the billing node, general node, or technical node based on the logic that we're gonna decide using the categorization node and the router function. So let's now see how it works. So first we need to define the state. So our state now is going to consist of the list of messages as usual, as always. So as I told you, generally when building AI agents, we're building conversational agents. We're building agents that carry on a conversation with the user. That's why we need the list of messages, and also we need the category. So the category is going to store the category that has been classified or categorized by the categorized node, right? So we're going to see how it works. So this is the categorized request. So this is the categorized node, basically. It takes input a state as usual and returns also a state. So most of the LangGraph nodes, they take the state as input, and also they return the state as an output, and they return the fields that needs to be updated in the state. So for example, here we have the LLM. So basically we need to do the classification itself. It's going to be done using an LLM. So we're going to use Claude 4.5 Sonnet. And then we take the user message, the last user message. So as we can see here, we're taking the last user message from the list of messages, and we're taking its contents, and then we're giving it to a prompt. So here the prompt said, you are a customer support router, categorize this request into one category, either billing, either technical or general, based on the user message, right? And then we're telling it to respond in single word, either billing, technical or general. So now what we do, we run this LLM. So we invoke the LLM, we call the LLM using the prompt and using the user message, the last user message. And then we return the categories, right? So because the LLM is going to return one word, so we strip it like trailing from any trailing spaces. And then we convert it to lowercase. And then we put it in the state. So we return the category, which is returned by the LLM. We put it in the state. And therefore, we update our state, we update the support state by adding the correct category that has been predicted by the LLM. So this stage now is finished. Now we're going to define the specialized LLMs. So for each one, we're going to be also using Claude Sonnet. So for the billing agent, we're just telling it you are a billing specialist, help with payments, invoices, refunds, etc. And then we invoke the LLM. So we invoke the LLM using the system message, which defines the roles of that LLM. And then we give it also the messages that has been exchanged so far with the user. So we give it the conversation, and we give it the system message, and we tell it to resolve the user query. Hopefully it has been, when we reach a billing node, it's hopefully a billing question, right? Because it has been categorized by the category LLM. Same for technical specialist. LLM, we have a system message about like technical support, and we also pass the conversation. And then it returns the messages, the updated messages with the response from the LLM. General support, the same thing. It also, like, we give it the system prompt, and we give it the conversation, and also it returns the response. It updates the message's state using the response. And now we have the key, which is the route to specialist, which is the router function. So now the categorized node, it invokes an LLM, it writes the category onto the state, right? So as we see here, we're writing the category to the state. Now we need the router function to take that state and route the execution to the corresponding node. So it takes an input, the state, and the output, it outputs the node names, as we discussed, billing, technical, general, and it reads the state. So it reads the category from the state. So this router function will run right after the categorized node, and it's going to look at the category, and it's going to see, is the category billing? If the category is billing, it returns billing. If the category is technical, it returns technical. If otherwise, it returns general. And by default, it also returns general if for some reason the categorized agent couldn't write any any category to this state. So now we define the graph. We give it the state. We define the nodes. We have the categorized node, billing node, technical, and general node. We have this. We add an edge, not unconditional edge, normal edge, from the start to categorize. And now here the magic happens. We add the conditional edges, right? So we define the conditional edges. Here's the built-in function in LangGraph, add conditional edges. It needs three things as input. First, the source node, right? In our case, it's the categorize, which is the name of the node, categorize. Then it takes the router function, which is going to read the state, and it's going to return the name of the nodes to route to. And then here we have the mappings. These mappings are mappings from the output of the router function to the actual names of the node. So if the output of the router function is billing, then we route to the billing node. If it's technical, we route to the technical node. And if the output of the router function is general, we route to the general node. Now, all specialists, they will go to the end. So we add the edges from billing to end, from technical to end, from general to end. And now here we define the memory. I have explained the memory in detail in the previous video. So now here we add it. All this does is it saves the memory, it saves the state. It persists the states between the turns of the conversation. And we save it in a check pointer, and we give that check pointer to the compiled graph. And now here we can now test it. So how we test it? We first run the create support agent, which creates the graph. Then we define the input, which is the configuration, and we pass to it the thread ID. This thread ID is going to help us to persist the messages throughout the conversation with this agent. So we're going to call it support demo, and then we're going to ask it multiple questions. So let's see how that runs in real life. So let's run the code. Python conditional routing. So first we ask it a test one, billing question, right? So user says, I need a refund for my last payment. So now it was categorized as billing, which is correct. So as we can see here, we run the agent, we pass the message, I need a refund, and we pass the configuration. So using the message, the agent decided to categorize it as billing, which is correct. And the billing specialist then said, I'll be happy to help you. I get together some information. So it's basically just, it routed to the billing agent, and the billing agent then started to ask a question concerning that matter. Now we make another technical question. I said, why am I getting 4 error? And then the agent decides to categorize the question as technical. So it pointed to the technical agent. The technical agent said, I can help you troubleshooting. This means that the page resource you're trying to access cannot be found, whatever. So it tried to give it common causes and solutions, whatever. So it tried to give it support, like technical, about the user's issue. Now the third one is a general question. I said, hello, what services do you offer? Then it says the categorized node categorized this as a general request, which is correct. And then it says, I'm here to help you with a variety of things, general support, account questions, how can I help you today, whatever. So that's it. We have seen how the categorized node was able to categorize user queries based on the topic, either to billing, general, and technical. We have seen how to do that in LangGraph. So yeah, that's all I wanted to share with you in this video. Thank you so much if you're still watching. I really appreciate it, and that's why I'm making the videos. Thank you so much again for watching. Stand by for the next episode. Bye bye.